Hi students, love you. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaram. Students, in this utilization through topic wise MCQ series, we have completed 3 sessions. It is the fourth one. Okay. So students, if you want previous, you can click on playlist. You can find out the previous sessions. Okay. And students, if you want to download the PDF, you can download from sunilengineeringacademy.com and you can join Telegram group. Okay, at the rate Sunil Engineering Academy. Let us start the session, guys. Coming to the first question, guys. Radio interference generally results due to dash. We have already discussed this type of question. Interference. When we will get the interference, whenever there is a high inductance, then there is a chance of interference. Okay. So in the following lamps in which we are using the inductance, GLS lamps, filament, no. Halogen lamps, no. Sodium lamps, no. So mainly in the fluorescent lamp, we are using the choke coil, correct? Choke is nothing but inductor. Okay. So in the fluorescent lamps, there is a chance of radio interference. To avoid this one, what we are going to add? To avoid, we are going to connect capacitor. So if you connect capacitor, then you can avoid the interference. Okay. Coming to the next question. Which of the following instruments is used for comparison of candle powers of different sources? Candle powers of different sources. So here candle powers belongs to light. So that meter is nothing but photometer. That meter is nothing but photometer. Okay. Dash cannot sustain much voltage fluctuations. We know very well this incandescent lamp or filament lamp, this life proportional to voltage power minus 13 or minus 14. So inversely proportional. Okay. So as the voltage fluctuations are more, life is going to be decreases. Correct? Life is going to be decreases. Okay. So it is more dependent on voltage fluctuations. So it cannot sustain for much voltage fluctuations. The flicker effect of fluorescent lamps is more pronounced at dash. So in case of fluorescent lamps, the flickering effect mainly due to lower frequencies. Lower frequencies. Very important question, that one. Which of the following lamp gives nearly monochromatic light? Monochromatic light, that is sodium vapor lamp. In street light, we are using sodium vapor lamp. Na? It will give monochromatic light. A mercury vapor lamp. I think this question we have already discussed. Na? Mercury vapor lamp, greenish blue color. A greenish blue color. Okay. Magnesium vapor lamp, that is greenish color. Okay. Greenish color. In case of high pressure mercury vapor lamp, that will give white light. Okay. High pressure mercury vapor lamp. Okay. Coming to the next one. Yeah, there is a question. Okay. High pressure mercury vapor light gives or contains dash color, that is white color. So the answer is option B. Coming to the next one. In a fluorescent tube, circuit choke act as. So many times we have discussed choke. It does not allow the sudden changes in current, so it stabilizes. Okay, stabilize the arc and also initiate the arc. So current limiting device. Current limiting device. In which mode of heating the heat transfer from one part of substance to another part without the movement of molecules? So the molecules motion, the heat transfer from molecule to molecule in case of convection, indirect contact, convection principle. Okay. So in case of conduction, we don't have molecule to molecule. So that is answer is option A. Here direct contact. Okay. Heat transfer by direct contact, that is nothing but conduction. Convection, indirect contact. That means, for example, if you want to heat the water, we cannot heat directly. What we have to take? We have to take one vessel and we have to heat the water. correct? Then heat will be transferred first of all to the vessel. From the vessel to water. In the water, the heat transfer from molecule to molecule, molecule to molecule. So molecule to molecule takes place in convection process. Okay, conduction means direct contact. That is, if we are heating the vessel, okay, that is heat transfer from fire to vessel is nothing but conduction. Radiation is nothing but without any contact. We are getting the heat from the sun. We are getting the heat from the sun is nothing but radiation. Radiation process. So radiation, for through the radiation we can heat very fast. So it is the fastest mode. Okay, conduction mode is the slowest mode. Okay, coming to the next question. A perfect black body is one which dash. What is a perfect black body? Which absorbs all the light. Okay, which absorbs all the light, or which absorbs all the incident radiation is nothing but black body. Okay, in case of white body, it may be reflect entire radiations. Okay, it may not absorb anything. A body reflecting entire radiations incidenting on it is called, that is nothing but white body. Okay, so in summer we can observe, if we wear very black or very thick color pant or shirt, then we feel very hot. Okay, if you want, you can observe in the summer. Okay, if you wear very tight and very dark color pants, okay, then you can observe a lot of heat. Okay, because of that absorbs all the radiations on it. But white bodies may reflect. The highest value of thermal conductivity is dash. Thermal conductivity, which allows the heat through it. So that is nothing but copper. Copper is the best conductor of thermal. Okay, that is best conductor of heat. So the conductivity is higher for copper. Okay, that's why the copper is used in the heat exchangers. In the ACs also we have the heat exchangers are there now. So the copper is mainly preferred. Radiations from a black body are proportional to, this radiations from black body is proportional to T power 4. Okay, T power 4. We have the heat dissipation formula. Heat dissipation formula 5.72 into 10 power 4 KE T1 by 1000 whole power 4 minus T2 by 1000 whole power 4 per meter square. So that means here proportional to T power 4. So the answer is option D. Okay, coming to the next one. The material used as heating element for furnace should have dash. For furnace, heating element must be having high resistivity. Yes, if it is a high resistivity, then high resistance, it absorbs some more power. High melting point, yes, otherwise it will be melt faster. Low temperature coefficient, yes. So all the three options are correct, means you can say all of the above is the answer. Okay, all of the above is the answer. Very easy question. The material used for heating element should be of high resistivity so as to. Why we require high resistivity? Okay, if you go with high resistivity is rho is high. Okay, R is equal to rho L by A. Correct? Rho L by A. So if you want to get same resistance, as resistance you want to get the same. If your rho is more, then your length is less now. As your rho is more, that means as resistivity is more, you can go with very less length. Okay, then also you will get the same resistance. Then if you get the same resistance, then you will get the same power. Okay, so you can get lot of heat. So R is equal to rho L by A. So if you are going with a material which is having high resistivity, you can use very less length. Okay, very less length. That is the main advantage. Otherwise you need to go with a very long length, then the size of the equipment is going to be high. That is very difficult to handling, transporting, and all. So many problems we will get, and cost also more. Okay, so we need to reduce the length of the heating element. Okay, to reduce the length, only option we can increase the resistivity. Okay, so that means we have to use the high resistivity material. Okay, Coming to the next one, the material used for heating element should be low temperature coefficient. Why low temperature coefficient? Okay, so why low temperature coefficient we need to use? To avoid the change in kilowatt rating with temperature. So we need to stable the kilowatt rating with respect to the temperature. Okay, if the temperature is more, then kilowatt rating again changes. We may not get a perfect heat. Okay, what we require. If we require 1500 degrees centigrade, we need to give that much of power only. Okay, if the element is going to be changed with respect, element resistance is going to be changed with respect to temperature, then we may get other readings. Okay, so that is not a requirement. Okay, that is not our requirement. So to avoid the change in kilowatt rating, that is power rating with the temperature. The following which are examples of direct resistance heating? Direct resistance heating. So we have the direct resistance heating are electrode boiler and also salt bath furnace. Okay, resistance oven is not a direct indirect, it is the indirect case. Okay, so the answer is option D, both A and C. Both A and C. Coming to the next one. In the following which are examples of indirect resistance heating? Indirect resistance, yes, immersed water heater. So here we are heating the element and that heat will be transferred to the water. So it is indirect contact only. So resistance oven and also room heaters. So all these are indirect resistance heating. So the answer is option D, all of the above. Option D, all of the above. In case of immersion type water heater, the heat is transferred. Heat is transferred. In case of immersion type, heat is transferred through the radiation, through the conduction, convection, and all of the above. Mainly heat is transferred through the convection process. So the answer is option C. Okay. So here, first of all, heating element is heated. Heat will be transferred from here element to water. Okay. Then the water, there is a molecule to molecule heat transfer takes place. That is nothing but we can say convection. The resistance ovens, the heat transfers to the charge by, in resistance oven, some of the will be convection and partly by radiation. Okay, without contact also heat is transferring now in the ovens. Okay, so in the ovens you can observe, if you place any one food item, it will be heated without any contact. Okay, so without any contact means radiation. After that, the heat transfer inside the food, inside the molecules. So molecule to molecule transfer takes place. That is nothing but convection. Okay. Temperature of the furnaces can be controlled by. How we can control the temperature of the furnaces? By changing the resistance? Yes. We can change the resistance means temperature changes. That is power changes. Power changes means temperature changes. Changing the applied voltage? Yes. Power depends upon the applied voltage and also current. Changing the ratio of on and off times? Yes. If it is more on, then we can get higher the temperature. So all above. So answer is option D. Which of the following heating element can be give the highest temperature of resistance heating? Very, very important question. That is silicon carbide. Silicon carbide having high resistivity, so we can go with a very less length. Okay, because of high resistivity, high resistance, higher power consumption, so we will get lot of heat. So that's why we can go with generally semiconductor items. Okay, silicon carbide. Answer is option B. Indirect arc heating. Okay, here indirect arc heating is used for dash. Indirect arc heating, the melting of ferrous metals, the melting of non-ferrous metals, the drying of paints and varnishes, any of the above. Any of the above. So here indirect arc heating generally used for non-ferrous metals. Very important. Indirect arc heating is used for melting of non-ferrous metals. In case of those are ferrous metals, that is in which we have the iron, then we can go with the direct arc heating. Okay, no need of indirect. So in non-ferrous metals case, we can go with the option B, that is indirect arc heating. The radiant heating, through the radiation process, without direct contact. So without direct contact, we can go for paints and varnishes. Okay, so if you heat directly, these paints and varnishes, those have alcohol. So alcohol can catch fire. Okay, can catch fire. So if you direct going to heat, it will be catch fire. So we need to go with the radiant heating. Okay, through the radiation process without any contact of direct fire to the paints. Okay, the most preferred method for the food process. For the food processing, food is generally dielectric, so dielectric heating is used. Okay, very important for this. For arc heating, the electrodes use made up of dash. For arc electro heating, we need to get some semiconductor type, and also we must require some high conductivity, and we need to get some high temperature with a stand. For all those, it satisfies the graphite, so we go with the graphite. Okay. Usually, arc furnaces are of dash. Arc furnaces are generally cylindrical type or conical type shapes. Okay. Induction heating takes place in dash. Induction heating generally takes place in conducting materials. Then only you can get the induction process. Conduction materials, maybe those are magnetic or non-magnetic. And induction principle, whenever we have the induction, that principle depends upon the frequency, okay, which is the high of value. So we go with a very high frequency. Induction heating, the depth to which the current will penetrate is proportional to dash. This current will penetrate proportional to 1 by frequency power 1 by 2. That is nothing but I proportional to 1 by root frequency. Very important question. So the answer is option A, 1 by frequency. The supply frequency usually employed for high frequency eddy current heating. So they are asking high frequency, that is in the kilohertz. So 10 to 400 kilohertz. Okay, 10 to 400 kilohertz. So dielectric loss is proportional to, we have discussed so many times, dielectric loss is equal to omega square, v square omega c delta tan delta. Okay, so that means it is proportional to frequency. Okay, v square omega c tan delta. So that is proportional to frequency. Okay. The heating of plywood, the frequency should be dash. So here we can observe so many questions are belongs to frequency. So we need to complete this data about the frequency with respect to the heating. Okay. So try to complete all the data about this heating with respect to frequency also. Okay. So heating of plywood, the frequency should be very higher, that is 1 to 2 megahertz. Okay, 1 to 2 megahertz. Okay students, we will discuss the remaining questions in the next session, guys. Okay, and if you like my effort, if you feel these sessions are useful, okay, then don't forget click on like option. Okay, and students, getting MCQs in the utilization is very difficult, and topic wise MCQs a lot of difficult. Okay, so here through these sessions you are getting all the content is free. Okay, and you will get a little bit explanation, but that little bit explanation will have, that is some sense, I think. Okay, so in the nowhere you can expect this little bit information also. Okay, so if you like my effort, don't forget click on like button at least, and if you want to encourage more, you can do in the comment section also. Okay, and students, if you want download the PDF with a lot of data and this MCQs, you can download from sunelengineeringacademy.com. Okay, okay students, love you, thank you so much for watching, take care, bye guys.